So last time we introduced the notion of procs, and I think when we wrapped up, I just left you with a teaser. There is a reason why we use procs. They actually help us. So one of the things that procs let us do is they help us eliminate redundancy. So if I have a block and I want to use a block over and over again, without having that proc construct that we looked at, we would have to recode that block every time. Because remember, the block is just something that's attached to the function. And if I didn't have this ability to kind of give them names, create procs that represent these blocks of code, I wouldn't have a way to pass them around. And what we'd end up with then is code that's kind of repeated, isn't it? We'd have to use the block, and if I needed that block again, if I didn't have any way to get a handle of it, I would have to go and specify that code again. And that violates a really basic principle of software development, right? One of the principles that we learn is don't repeat yourself. As soon as you find yourself repeating something, early on you might have learned you put it in a method and then call it, because then you can call it in more than one place. So this dry, don't repeat yourself principle is important. And procs is one way in Ruby that we can avoid entering in that same block of code multiple times. So let's take a look at an example just to make that clear. We'll look at an example, and I'm going to just create a couple of arrays here. So I'll have an array of two arrays of integers, and I'm just kind of randomly creating these. I'll call this one vals1, and then I'll have another one called vals2, and I'll have slightly different values in it. And so that's my data, let's say. And let's say I want to do some computations on these things. I want to process them, and let's say I have multiple sets of data like this. And one of the methods I can use is called collect. And collect it's an iterator on array, and it will visit every element and do a computation on it. And so I can do something like this. I can say vals1 collect, and I can give it a block of code here. And let's say I want to replace, in fact, let me do that. So there's a couple of different versions of this. I'm going to use the one with the exclamation mark, and I'll explain that in a second. And let's say I want to compute the cube of every value in this array. Okay, so this syntax here will let me do that. Now, just as an aside, that exclamation mark on the collect method name there, in Ruby, we can use that exclamation mark in our method names. So it's a valuable character in our method names. And we can use that to designate that this function or this method is actually going to change the object that it's working on. There's also a collect method without the exclamation mark, and what it does is it returns us a copy of the modified value. Okay? Another thing we'll see in Ruby method names is we can use the question mark at the end. Okay? And we'll use that to recognize the fact that this thing is returning a Boolean, and we can use it in a condition. Okay? So exclamation mark, when you see that on the end of a Ruby method name, and you can introduce that yourself in your classes, means be careful, this thing is going to modify the data. So it's going to do cubed on my input array in place. If I did collect without the exclamation mark, it'll call the version of the method that returns a copy of all the values cubed. So that's the first one, but let's say I want to do this on multiple arrays. Okay, so if I had to do this again using this syntax, I'd have to go like this, and I'd have to repeat this code block. Now, that's not a complete disaster here, because my code block is like less than 10 characters here, so it's not a big deal. But keep in mind that your code blocks won't always be so trivial, will they? And so we know that instinctively now at this point as developers that anytime we repeat ourselves, we're doing more work than we have to do, and if we made a bug the first time around, we're likely to replicate that or introduce a bug when we re-enter that code later or copy paste it. So let me just run this to show you that it works. Oops, I forgot to put S, sorry. The difference between running in the interpreter and the okay, so it just computed the cube of each of those values in the array. But in reality, there's a better way to do this with procs. So let's go down here, and I can say something like this. I can say, create myself a new proc, pass it the block, okay, so now I've got a handle to that block of code, and I can do something like this. And then I'll pass and maybe we'll just put a little indicator here so we can actually see the difference between the output when we run it. Okay, so I've taken the same block of code, that reference, which is a proc, and I've passed it to this iterator in two different situations. So I wrote the block once. Oopsie. Okay, so I forgot my ampersand. So I owe Chris a beer or something.
You did also have to reinitialize those arrays too.
Right, because otherwise they're going to be huge and they're not going to cube.
Or you could have just removed the exclamation point.
I did that though and it didn't work. What version of Ruby are you using?
I mean, to avoid the overflow.
All right. The second reason though is that what if we have a method and we would like to pass multiple blocks to the method? Okay, so Ruby in its native form supports method name, parameters, list of parameters in parentheses, and then an optional block of code or an ampersand block reference, right? So if we want to pass in multiple blocks to a method, we can actually use a similar approach. So let's go to another example and take a look at how we could do this. So what I'm going to do is define myself a function that does some work, and it's going to take a bunch of procs as input, and I'll show you that in more detail when we actually invoke this thing. But you can think of procs here. It's actually going to be a hash. So whenever we start processing or doing our work, I'm going to call the proc that's associated with the symbol starting, and then I'm going to do some work. So I'll just represent that with a string here, and I'll say doing first part of my task. And then I'm going to do another call to a block, and I'll call this one progress. And I don't need these blanks really, because you can. And then I'll put a different message here. I'll say doing second part of my task, and then before I leave, I'm going to call one more thing here. Okay, so notice I'm expecting a hash of procs coming in here, and I'm going to call them from this single method. So to call this thing, we'll do something like this. We'll say do some work, and then I'm going to create my hash. Question?
You spelled some wrong.
Thanks. Pair programming. All right. So I'll say starting maps to, and I'm going to create myself a new proc right here. And I'll have this proc do this. And then I need one called progress. And this one is just going to say making progress. And then I'll have one more that's called finishing. Thank you. I think it's just the syntax highlighting in Ruby that's treating it like a class name. All right, I think we got that all right. So the idea here is I've just created 3 procs, and I've set them up in a hash using 3 symbols, 3 different symbols. Then when I call my method, I pass that whole hash in, and then at strategic points in time, that method's going to call those blocks of code that I gave it. So in effect, I'm passing multiple blocks into a single method using this technique. Okay? Next topic. It's a little more fun. So let's talk about lambdas. Okay? Lambdas. So the term lambda comes from lambda calculus, which is a branch of mathematical logic that has been heavily applied to the area of functional programming languages. Now, we haven't talked about functional programming languages yet in this course, except to mention the fact that they existed the very first week that we met here. But we are going to move into functional languages next. And the reason I chose Ruby as a good language to discuss after C is because Ruby does support some of the features that we're going to need in functional languages. So it's a nice transition from a purely imperative language to more of a hybrid language that has certain aspects of functional programming. And then from there, we'll move into more pure functional programming. So in Lisp, the term lambda refers to a function that we can manipulate as an object. In other words, we can pass this function around, just like we would pass along a piece of data that we had an object reference to. And the best way to understand this is let me just show you some syntax of how we can create a lambda and pass it. And then we'll actually talk about how they're different than procs, because your instincts are going to be, how is this different from procs? It looks just like it, you're just using a different keyword. So let me do the syntax first, and then we'll talk about those differences. So I'm going to open up an existing class. So array is an existing class in Ruby. And remember, in Ruby, we can redefine our classes on the fly. So we can add new methods, we can change existing methods, and so forth. So I'm going to open up the array class, and I'm going to add a new method called iterate, and I'm going to put a bang on the end of it. And in this function, I'm just going to visit each, and I'm going to use this particular iterator. And my block here takes more than one line, so I'm going to pass it the parameters using the do, and then I'll end my block with an end. So I'll assign to each index location Okay, so I'm going to assume that code coming in is a block. In fact, I'm going to assume it's a lambda. And I'm going to call whatever that is using code.call, passing in the n value. So n is going to be the value in the array itself, and I is going to be the index that my iterator is currently on. So when we call this, I first need myself some data. So I'll create myself a little array. And then I can create a lambda, and I'll call that iterate function that I just defined. And to create a lambda, I use the word lambda, and then I create my code block. And when I'm done, just to show you that this thing mutated my array, basically computed the square of each value, I'll print it out. Okay, so this lambda so far kind of looks and acts like a block. Let's run it. Okay, and it did exactly what you probably expected it would do. Prints out the square of each model. And you might be saying at this point, what's the difference between a lambda and a proc? And these are often confused by a lot of people, even Ruby programmers. But there are a couple of differences between lambdas and procs. The first difference is that lambdas check the number of arguments passed. If I pass the wrong number of arguments when I call a lambda, it's going to have a problem. So let's prove that out with another example. So we'll write a really simple method here, and we'll expect a block to be passed in. I'll do a little parallel assignment, and then I'll call my block, and I'll pass in these two variables. Okay, so there's a simple method that calls a block that I'm passing it with two parameters, and then we'll create, first of all, we'll call it with a proc. So I'll call proc new, and in my proc I'm going to pass 3 parameters. And let's see, on this last one, I'll go like this. So that's one. So I've got a proc that takes 2 arguments, and a block that takes, I've got a function, a method that calls a code block assuming 2 parameters. And I've just created an invocation to that function passing a code block that expects 3. Okay, so that's one. And now let's do the same thing with a lambda. So we'll say args, and then we'll say lambda, and we'll put in our new code here. I think it's going to be the same, so let me do it like this. And we'll change this to lambda. Okay, so it's the same, it's just in one case I'm sending a proc, the other case I'm sending a lambda. And if we run these, again, I think I'll need to do, well, no, I don't need to do anything because it's just going to print out inside there. So let's do this. Okay, so you'll notice that the first time I invoked it with the proc, it printed out the 2 first arguments, 1 and 2, and then for the third argument, which is undefined, right, because my proc only was invoked with 1, it actually padded it out and sent a nil in. So the actual class is nil class. But when I called it with the lambda, I actually got an error because there was the wrong number of arguments. I sent in 2, and the lambda actually expected 3. Okay, so that's one difference. Lambdas actually, when they're invoked, when they're yielded or called to, You have to send in the exact number of arguments or you'll get this exception. Okay, any questions so far? So that's one difference between lambdas and procs. The second difference is that lambdas have diminutive returns. And what that means in practice is that your proc, when a return is encountered inside a code block with a proc, it actually stops the method that's yielding to the block and returns. Okay? So when you have a return in a code block and that code block is being represented or accessed via a proc, it's going to cause the method that's yielding or calling to that block to return right at that point. Okay? Lambdas, on the other hand, will return their values to the method and allow the method to continue executing. Okay, so when I do a proc, if I run into a return in that code block, the game's over. Not only is the block done, but the method that called it, that return is treated as a return to that method, so I'm out of there. I'm gone. If I send in a lambda and there's a return in there, the lambda is going to return, but control and the return value goes back to the invoking or yielding method. Let's look at an example to make sure we understand this. So I'll define a method called proc return, and I'll create a block that returns the string when it's called. And then from my method, I'll return yet a different string. And I'll define a second one called lambda return. And I'll create a lambda here. And I'll have it return lambda. And a different message. And if I call these methods, I'm going to see that different behavior. So let's try it. Okay, so when I called the first one, it returned proc.new, and when I called the second one, it returned lambda underscore return method finished. So if we go back to the code and look at what we did, when I hit this return statement right here in my proc, it actually returned from the entire method, right? So I didn't even see this thing getting returned at all. That statement was completely obscured by the fact that I hit a return in my proc, so it returned all the way. On the second one, I saw this message printed out. So when I called that lambda and I hit this return inside the block, instead of returning from the method, it returned to the function and the method, and the method continued running. So everybody see that? So this is my second difference between procs and lambdas. First difference, procs checks the number of arguments. Lambdas check the number of arguments, procs do not. Procs will pad us out with nils if we don't send in the right number. If we send in too many, it will ignore the parameters that we've sent in addition. Second difference is the return behavior. Lambdas return to the method that yielded or called. Procs return from the method that are yielding or calling. Okay, so conceptually, the way I try to remember this is procs are like little code snippets. Procs are like cut and paste, okay? And it just does a literal paste of the code right where I want it. So if I've got a return in there, it's as if you're taking the code in that block referenced by the proc, and you're just kind of sliding it right into the method. So if there's a return in there, that method's going to return, right? It's like doing a search and replace in your program. If you're replacing with a return, wherever you hit that return, you're out of there. A lambda has much more of a method call-like behavior, where you're actually checking the arguments on the way in, and you're actually returning back to where you called on the way out if you do a return. Okay, so that's the way I conceptually think about it. Lambdas, really act like methods, even though they're something we can pass around and handle like an object. Procs really are kind of like code snippets that we're cutting and pasting and putting into our method at a certain place. So conceptually, lambdas let us write methods in kind of an anonymous type way, right? So it's like writing methods. They have the same behavior as methods, but we're writing them in a more anonymous way, and we can kind of pass them all around. There's a really nice argument or article on this particular topic, and I will post a link to this. This is one of the most coherent, well-articulated write-ups I've seen to date on the difference between procs and lambdas. In fact, some of the code snippets I just showed you, I pulled out of this argument, or out of this article. Sorry. So I'll put this link right in the video for you.